Today, we are diving into a really fascinating new study. It connects the trillions of microbes living in our gut to the front lines of the fight against childhood cancer. It's a story about a powerful, life-saving treatment, a really dangerous side effect, and a hidden clue that honestly could change everything. So let's get right into it.
And a huge part of the story is where it's coming from. See, this research isn't from one of the usual hubs in the US or Europe. Nope. This pioneering work is happening right now in Cairo, Egypt. And that gives us a vital and, frankly, long overdue new perspective on this problem.
Okay, so let's set the stage. Our story kicks off with a team of incredibly dedicated researchers and doctors who are facing one of the toughest challenges you can imagine in pediatric medicine.
They're fighting something called acute myeloid leukemia, or AML. It's a really aggressive cancer of the blood and bone marrow. And, while treatments have gotten so much better over the years, the fight is still just incredibly intense for these young patients.
And here is the core dilemma. The very weapon that's used to save these children's lives, that intensive chemotherapy, it's a real double-edged sword. It's fantastic at killing cancer cells, but it also wages war on the body. It especially hits the gut hard, breaking down all its natural protective barriers. And that just opens the door for dangerous bacteria to escape into the bloodstream, which can cause these absolutely devastating infections.
So, to really dig into this problem, researchers at the Children's Cancer Hospital in Egypt focused on just 29 patients. That's it, 29 children with AML whose bravery is really at the absolute heart of this groundbreaking discovery.
And I really can't overstate how crucial this is. Almost all the research we have on the microbiome has focused on people in North America and Europe. This study from Egypt is one of the very first of its kind. It's filling a massive, massive gap in our global understanding and giving us a completely invaluable new set of data.
So, how did the researchers actually map this hidden world inside the gut? Well, their approach was actually really elegant and surprisingly simple. They took samples at three really important moments. First, at T1, that's before any chemotherapy, to get a baseline. You can think of it like a before photo of the gut's little ecosystem. Then they took another one at T2, just 7 days into treatment, to see the immediate shock to the system. And finally, at T3, about a month in, to see how, or even if, the gut was starting to recover.
And here's the cool high-tech part. First, they collected samples, and they pulled out all the DNA from trillions of these tiny microbes. Then, using some really advanced gene sequencing, they basically read the unique genetic barcode of every single bacterium to figure out who was who. After that, they used powerful computer analysis to just sift through that mountain of data to find the hidden story.
Okay, so what did all that data actually show? This is where the story gets really, really compelling. Let's look at the direct hit that chemotherapy had on these children's gut ecosystems.
The first big finding was just stark. There's no other word for it. The intensive chemo caused a major crash in the gut microbiome. The rich, diverse community of bacteria that's supposed to be there, it just collapsed under the pressure of the treatment.
And you can literally see that ecosystem crash right here in this chart. Before chemo at T1, diversity is nice and high. You've got a healthy, bustling community. But look at T2, just 7 days in, it's already dropping. By the end of the month at T3, it's hit rock bottom. The chemo has left the gut's natural defenses just severely weakened.
And it wasn't just that there were fewer bacteria. The types of bacteria changed, big time. Before treatment, a group called Firmicutes was kind of running the show. But after chemo, a totally different group, proteobacteria, started to take over. In gut health, you want tons of different microbes all doing different jobs. When one group, like this one, which has a lot of potential troublemakers in it, starts to dominate, it's a classic sign of what scientists call dysbiosis. Basically, an ecosystem in serious distress.
And here are those major players. In a healthy gut, you can see Firmicutes and Bacteroidea are the big slices of the pie. But after chemo, it's that smaller orange slice, the proteobacteria, that suddenly expands and throws the whole system out of whack.
So, the gut ecosystem is in total chaos. But how does this connect back to those dangerous infections that doctors were trying so hard to prevent? Let's take a look at the clues the researchers started to piece together.
Right, so as the gut's defenses started to crumble, an opportunist showed up, a bacterium called Klebsiella, which can be really dangerous and is notorious for being resistant to drugs, was pretty much nowhere to be found before treatment. But as soon as the chemo started, it appeared, and its population just began to grow.
Then, the researchers found something really useful.
They discovered that the bacteria they could easily grow from a simple stool culture, like that Klebsiella or another one called Enterococcus, were the exact same ones that were taking over the gut. This was huge. It meant a simple, low-tech test could act like a really powerful window into this super complex world.
But then, the data revealed a twist, a real mystery. While the gut culture was great at predicting which microbes were dominant in the gut, it was terrible at predicting which ones would cause sepsis, the most dangerous kind of bloodstream infection. In fact, in most cases, the bug causing the infection in the blood did not match the main bug in the gut. This was a massive, totally counterintuitive finding. It suggests the most dangerous infections might not be breaking out of the gut at all, but could be coming from somewhere else entirely.
So we've got a crashing ecosystem and a surprising mystery about where these deadly infections are coming from. What does all of this mean for the future of treating these kids? Let's connect the dots.
And this is really the aha moment. The researchers found a direct, critical link. The children whose gut diversity crashed the hardest were the most likely to develop a dangerous and painful gut inflammation called enterocolitis. So the health of the microbiome wasn't just some interesting detail, it was a direct predictor of a life-threatening complication.
As the researchers themselves put it, this loss of diversity isn't just a side effect, it's a predictive signal. It's a tool that could one day help doctors identify which patients are at the highest risk before they get critically ill.
And this brings us right back to where we started. This is so much more than just a single study. This incredible work, from the Children's Cancer Hospital of Egypt in collaboration with Cairo University, is literally laying the groundwork for a future where cancer treatments can be made safer and more personalized for children all over the world.
Which leaves us with this really powerful question for the future. We tend to think of cancer treatment as targeting the tumor, right? But what if the key to survival also lies in protecting this fragile, invisible ecosystem inside of us? Could a simple stool sample become one of our most important tools in making these life-saving therapies safer for every single child?